Hi, my name is Jaden Pauling, and this is the Physics 2212 Lab 3 Magnetic Fields of Bar Magnets. The purposes of this lab are to calculate magnetic dipole moments using experimental data, use the Biot-Savart law to observe the distance dependence of a bar magnet, and to compare real-world calculations of the magnetic field to computational models. Out of the four statements presented to us, number 1 and number 4 describe what I had observed while conducting this experiment. When the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction. As the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. After using the bar magnet given to us and inputting the data into this Excel sheet, I was able to use these calculations to solve for the average magnetic dipole moment of the bar magnet. Using this magnetic dipole moment, I was able to model the magnetic field of the bar magnet as seen in this coding slide. Note that the magnitude and direction of the magnetic field of the on-axis observation points are equal on either side of the magnet. The magnetic field at the perpendicular observation points are also equal in magnitude and direction to each other. In conclusion, the magnetic field of the Earth, other surrounding electronic equipment, and metals can greatly affect the accuracy of your data and calculations. The location of the magnetometer chip inside of your data collection instrument is also very important, as well as the Biot-Savart law is extremely useful in calculating magnetic fields hypothetically and in the real world. Questions. What if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? If I hadn't oriented my experiment to compensate for magnetic north, a component of the Earth's magnetic field would have pointed along the x direction, and my results would have been off due to the principle of superposition. What if you were to stick two identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? If I were to stick two identical magnets together, I would expect my results to increase by a factor of 2 due to an increase in the total magnetic dipole moment. Thank you for listening and watching, and have a good day.